Sampling methods. When conducting a survey, the first thing we should do is to identify the population we want to study. Next, we need to select a survey method. When doing so, we should try to avoid bias. So sampling bias is every member of the population does not have an equal likelihood of being in the sample. We should do our best to avoid this. Now, sampling variability is a natural variation of samples. It's unavoidable and expected. And in most cases, it doesn't cause any problems. So we're not going to be able to avoid variability, but it's just the way it is, okay? In a random sample, each member of the population has an equal probability of being chosen. So, say for example, you have every member of the population with an ID, right? Each individual, I can't spell, individual has an ID number. A computer generates I guess this isn't exactly what this said in the other video, but this would also work. A computer chooses, I guess that's what this is saying. Computer generates random IDs. Say a list of random IDs. Those people are surveyed. I keep saying it different than I write it. Doesn't really matter to me. I'm just kind of winging it anyway. I was trying to make it shorter. I don't think I accomplished that. Okay, so everyone has an ID number, a student ID, a driver's license number, ID number. Like, you don't have to have a driver's license to have a state ID number. You can just go get an ID card and it'll have a number, right? So then you take a computer program, tell it what the ID numbers available are, and have that computer generate a random list of a sample size to survey, right? Okay, now my struggle in this video is to understand the difference between random sample and simple random sample. Simple random sample, every sample of a particular size n is selected such that every sample has the same probability of being chosen. So random sample is about individuals. Simple random sample is about choosing different random samples. So that would be, you choose like 100 people randomly from the population, there's one random sample. Or you choose another set of 100 random people from the population and there's another random sample, etc. So I don't know how to write that down, but each sample rather than individual each individual. Has the same probability of being chosen. Or maybe we should phrase that a different way because it's said the same way in the thing. So is equally likely to be chosen. Does that sound good? Does that make sense? We understand the difference between those two? Because I was struggling. They're very similar. Okay, so random sampling. I feel like my handwriting is really not doing well on this today. Oh well. Stratified sampling. A population is divided into subgroups. Samples are taken with the sample sizes proportional to the size of each subgroup in the population. It can be used to select a sample in desired age groups, political parties, etc. So for example, a company wants to survey 200 of their employees, we're assuming they have more than that, with all age groups represented. The company's employees are 15% of their total employees are from the age of 20 to 29, 35% of their employees are from the age of 30 to 39, 30% of their employees are from the age of 40 to 49, and 20% of their employees are from the age of 50 to 59. How many employees should be selected in each age group to create the sample size of 200? Okay, so basically what we will be doing is taking the percentages of each age group and multiplying them times the sample size of 200, right? So it would be 0.15 for 15% times the 200 people in the sample. Now these are pretty easy because it's 200. It's basically just going to take the percents and double them. So that would be 30 employees. I don't think I'm going to write this out every time. Age 20 to 29. And then we would do 0.35 times 200, which would be 70 individuals from the age of 30 to 39. And then basically they would be divided up into these groups and this number of people chosen randomly, right? That's the idea behind it. And then 0.3 times 200 would be 60. Do you see how I'm getting these numbers by multiplying these out? Age 40 to 49. And then the last group would be 0.2 times 200. So that would be 40 between the age of 50 and 59. Okay, so that would be stratified sampling. Now, very similar to stratified sampling is quota sampling. Let's read this and see how that could be slightly different. Samples are collected in each subgroup until the desired quota is met. So employees are chosen at random from all employees to answer a survey. But when the proportional number of employees surveyed in a certain age group is met, employees in that age group are no longer surveyed. So with the stratified sampling, imagine we have 4 different hats. Not that that's how they would be selected. But the employees of each age group are placed in each hat. And then 30 are chosen from this hat, and 70 from this hat, and 60 from that hat, and 40 from the other hat. So that's stratified. Quota sampling would be, okay, here's all the employees. Let's choose random employees. Choose, choose, choose. Oh, look, we already have surveyed 30 of this age group. We can stop surveying that age group. Keep choosing random employees. Oh, that person's already in that age group. We don't survey them. But we just keep until we've met all those quotas. Do you see how it's just a very slight difference? I don't think it's going to make a much difference overall in the results. It's just a very slight difference in how they're randomly chosen. All right. Cluster sampling. Wait, did I call that cluster? Quota. Okay, quota. Okay, cluster. Population is divided into subgroups, which we call clusters, and a random set of subgroups are selected to be in the sample. For example, so some of these examples I left for you to fill in blank. Others I just typed them in there because I was like not sure how I would have you write them down exactly. So, a chain of 150 restaurants wants to survey its customers about a possible new menu. So instead of surveying all 150 restaurants, the clusters that are sampled are 50 of the 150 restaurants give out the survey to their customers. See how each store represents a cluster that's being sampled, right? Systematic sampling. Every nth member of the population is selected. Acceptable sample to avoid bias, even though it's not entirely random, right? So say, for example, you have an alphabetical list of students, and you're going to contact every 50th student. Contact every 50th student from an ordered list of students. So it could be alphabetical, it could be ordered by student number. So it's not actually random because it's just systematically choosing every 50th student that's on that list. So the concern that it mentions for that not being quite as good as just a random survey is that, like, for example, if it was alphabetical, then you might have two students that are siblings. Because they have the same last name, they would be listed next to each other in the list. But if one is chosen, the other would not be chosen because they are not right next to, because they are right next to each other in the list. So that is just a little bit not representing things evenly if it's not randomly chosen from everybody. But it's still better than these other two we're going to talk about right now. Okay, the worst two types of sampling because of bias are convenience sampling and voluntary response sampling. So convenience sampling, an example would be, well, convenience sampling is just selecting whoever's convenient. So like if I just surveyed the people in this class, that would be convenient sampling for me right now because you're right here, right? Maybe go to the mall would be an example. And survey the first 50 people you see. What should we do? Okay, and then voluntary response sampling is where subjects volunteer for the survey. These are usually skewed towards people who have particular strong opinions about the subject of the survey. So they're like, oh, I want to voice my opinion on that, I'm going to take the survey. Or people that have extra time. Oh, look, there's a survey in my email. I'm bored, maybe I'll do this, right? Awesome. So here's an example. Email, a poll, or survey. Those who respond choose to do so. I think